Hi, my name is Daksh Patak and I'll be teaching you trigonometry, AMC 10 to 12. Yeah, it's mostly for AMC 12, but for AMC 10 you might be able to figure out cool tricks for the geometry problems with trigonometry. Let's get into it. So first I'll give you a brief introduction about trigonometry. Trigonometry is the studies of relationship between angles and side lengths, particularly in triangles. In trigonometry, we need to be commonly using radians as opposed to degrees for representing angle measurements. You will also need to be familiar with both degrees and radians. What is a radian? We'll get right into it. Definition 9.1. A radian. A radian is a unit of angular measurement equal to 180 degrees over pi, about 57.3 degrees. Like 180 degrees divided by pi will be about 57.3 degrees. So the length of the arc is subtended by one radian sector of a circle, which is equal to the radius of the circle. Okay? So we'll go to example 9.2. We have to convert 120 degrees into radians. So when we convert something to radians, from 180 degrees pi is going to be the reciprocal of this, which will be pi over 180, which we will multiply it by 120. So 120 degrees will be equal to, what? Oh no, sorry, yeah. 120 degrees will be equal to 120 degrees times pi over 180 equals 2 pi over 3 radians. That's going to be our final answer for this example. Okay, so we'll go to definition 9.3. So in definition 9.3, we'll be using opposite and ADJ to refer the sides of opposite and adjacent to the angles labeled as theta, and HYP as hypotenuse to let triangle ABC to be a right triangle. So with the measure of C will be 90 degrees. The measure of C will be 90 degrees, okay? Let pi over 2 pi over 2 let be the theta of measure BAC. Okay, so means that 90 degrees will be equal to pi over 2. Okay, so then you have to let theta to be measure BAC. So that's sine theta, opposite side over hypotenuse will be equal to A over C. A over C, okay. Means that so you could say this is 2 and this is 1. So that means it would be 2 over 1 means 2. So if you gave these letters, I'll just give this one like 3. Okay. And then after that, and for the cos theta, it's going to be adjacent over hypotenuse. Means that adjacent is B, so B is 3 over C is going to be C is going to be what? 1. So that means this will be equal to 3. And last but not least, tan theta is going to be opposite over adjacent. Means that opposite over adjacent be equal to A over B. Means that 2 over 3. Oh my god, I'm right. 3 over 2. 2 over 3. Okay, so we just got this cleared out. What is the sine, cosine, tangent of a right triangle? We'll go to example 9.4. Damn, there's a lot of examples. Okay, so example 9.4 says that what is sine pi over 6, cosine of pi over 6, and tangent of pi over 6. So the corresponding right triangle with an angle pi over 6 is 30 degrees. Means that it's 30, 60, 90 triangle. Let me draw that out for you real quick. And when we meet about 30, 60, 90 triangle, this will be 90, 30, and 60. And this is going to be 2, 1, square root of 3. Okay, so therefore we have sine as pi over 6. Pi over 6, which is equal to 1 over 2. And cos, oh my, that's a lot of space for us. Okay, cos will be pi over 6 equal to root 3 over 2. And tan is going to be pi over 6 equals 1 over root 3. Now you might be wondering, how did we get 1 over 2, 3 over 2, 1 over root 3, root 3 over 2? It's all because of definition 9.3. As you could say, they're asking for sine. And over here, when they said sine theta, opposite over hypotenuse, means that A over C, you could say this is C, A, B, okay? A over C is easily 1 over 2. Okay, that's how we got this one. And then when they said that cos theta means B over C. So when they said B over C, it's root 3 over 2 for B over C. This will be A over C. So when they asked about tan theta, see, tan theta, it's opposite over adjacent means A over B, which is, that means 1 over root 3 will be A over B. So it's just definition 9.3, okay? This is just definition 9.3. So we'll move on to definition 9.5, which is sine, cosine, and tangent in a unit circle. So we'll just consider unit circle. Consider the unit circle and let P be x comma y. I forgot the comma. And be a point on the unit circle. Let theta be the angle formed by the positive x-axis and the origin. And point P, the sine theta, will be equal to y, and cos theta will be equal to x. And the tan theta sine theta over cos theta will be means x over y. Okay? That's just simple unit circle. So we could also, then we're going to go to definition, definition 9.6, which states that for any angle theta, CSC theta will be equal to 1 over sine theta, and sec theta will be equal to 1 over cos theta, and cot theta will be equal to 1 over tan theta, okay? Means that I'll write this in mathematical form so it'll make more sense. So CSC theta will be equal to 1 over sine theta and sec theta. What am I writing here? What am I doing? Let's just undo that. Anyway. So sec theta will be equal to 1 over cos theta, and cot theta will be what am I writing? 1 over tan theta. Okay, that's just in mathematical form. Okay, so what you might also be asking, what is CSC, sec, and cot? So CSC is cosine, and sec is secant, and cot is cotangent, okay? So let's get right into it. My bad, we had to do definition 9.7. So given any real number, x, this sign means a set of any real number. Okay, so given a real x set of -1 and 1, the inverse sine of x is denoted by the arc sine of sine to the power of -1x, which is equal to the angle theta of set of pi over 2 and pi over 2, which is such that sine theta is x. The inverse cosine of x is denoted by the x or cosine of -1, cosine in the power of -1 equal to set of 0 pi, such that cosine theta will be equal to x. Given that a real number, the inverse of tan will get x get denoted by arctan x, or tan to the power of -1 x will be equal to the angle of theta, which the set of minus pi over 2 and pi over 2, such that tan theta will be equal to x. Okay, so 9.8, they're asking in radians, what is tan to the -1 power times 1? We can just do the tan to the pi over 4 will be equal to 1. So that means tan to the power of -1 will be equal to pi over 4. Yep, that's the answer. So we're going to move on to trigonometric identities, okay? So here we go. Theorem 9.9. Here are some basic trig identities. Cos, I think I should write this in mathematical form. Let me write this like this, this, this. Okay, let me start writing them. So cos times minus theta will be equal to cos theta, and then sine, and that could also be sine times negative theta will be equal to negative sine theta. What am I writing? Sine theta. Okay. Oh, why am I writing parentheses? Okay. So for the next one, it's just going to be, okay, sine times pi over 2 minus theta. This will be sine, and for the cosine, I'll just write it over here. For the cosine, it's going to be cosine theta times pi over 2 minus theta will be equals to sine theta. So it's just kind of the reverse form of this and this and this and this, but I'll still write out for last two ones. I'll write this one out right here. Okay, sine over pi minus theta will be equal to sine theta. Oh my god, yeah, it's getting way too small, way too clumped up here. Okay, and cosine pi minus theta will be equal to sine theta. And for the last one, I'm just gonna write it right here. Sine times theta plus 2k pi will be equal to sine theta, and which will also be the reverse of cosine theta plus 2k pi, which is then equals to cosine theta. yeah, that's just theorem 9.9. So in theorem 9.10, it's going to be the Pythagorean identity. Really important. Here, I already wrote. Thank God I wrote this already in mathematical form. So in Pythagorean identity, sine squared theta plus cos squared theta will be equal to 1. And this, we got this how? By a squared plus b squared plus c squared. We all know that for the Pythagorean theorem. So we just decided to convert it. Remember sine was a over c and cos was b over c. Well, we just did this over here. And we just squared it because it's the, Pythagorean theorem. It will be equal to 1. Yeah, that's theorem 9.10. And of course, I have to write theorem 9.11 into mathematical form. Oh, at least I wrote everything else in mathematical form. Anyway, let's start writing. Alright, 9.11 states that tan squared theta plus 1 will be equal to sec squared theta, and then it'll be cot squared theta plus 1, which is equal to csk squared theta. That's just this full form of this, mathematical form of this. Then we'll go to theorem 9.12, addition formulas. So over here, sine theta plus or minus beta will be equal to sine theta over cos beta plus or minus sine beta over cos theta. Then we'll just say the same thing, but this you should watch out for. This means that it's going to be, if it's plus over here, then that means it has to be minus over here. It cannot be plus again, okay? This means that if there's plus in one area, it means that it has to be minus in the other area. Oh my god, I cannot write. Okay, so then number 3 will also be tan times theta plus beta, and over c plus or minus, but then now it's the same reverse thing. Oh my god, why I did that weird circle. Oh my god, my circle is beautiful. Yeah, so that means we'd be doing this reverse, means if this is plus, then this will be minus. Okay, that's all it just states. Okay, so theorem 9.13 is just double angle formula. Same thing here, just my handwriting is beautiful. Anyway, yeah, just I'll read out loud if you want. So s2 theta will be equal to 2s sine theta cos theta, and cos 2 theta will be equal to cos squared theta minus sine squared theta will be equal to 2 cos squared. Remember, do not forget these formulas. Important for the AMC 12. Okay? Important, So, minus 1 equals 1 minus sine squared theta. And tan 2 theta will be 2 tan theta over 1 minus tan squared theta. And yeah, we'll move on to example 9. Example 9.14. Okay, so in terms of A and B theta, the measure of C, let's see, okay. What is the area of triangle ABC? So trying to find the area of this triangle, but we will have 0 sides. Means that we could, we can drop an altitude here from A onto line BC. And this will already make this perpendicular to make this a right triangle. So let D be the foot of this altitude. D is equal to foot. Oh my god, my hand is beautiful. Foot of altitude. Okay, so by the definition of sine, you know, we would be having, goddamn, theta be equals to AD over B. So then AD will be equals to B sine theta. Therefore, the triangle ABC has a base of A, and a height of B. Oh my god, my spelling is so good. So good. Height of B. And that means its area is... Why is it random dot type? Okay. 1/2 A times B sine theta. Oh my god. Will be equal to 1/2 AB sine theta. You might be wondering where in the world you got this equation, but it gets it from theorem 9.15. Okay, it's just this. So there we have a triangle with side length of A and B, which meet at an angle C is 1/2 AB sine C. Okay, you probably understand that. AB with the sine of C. Okay, this is what it's all it's saying. Okay, then we'll move on to exercises. Just one exercise today. So we'll be computing the sine, cosine, tangent, and cosecant and secant of the cotangent of the following angles. This is gonna be a really long one. Okay. So we'll be using the sine formula, cosine formula, and tangent. So here we go. So number 1. This is gonna be so much fun, guys. Okay. So theta will be equals to pi over 4. Okay. So the known values are... So we know the known values are sine pi over 4 will be equal to root 2 over 2, and cosine of pi over 4 will be equal to root 2 over 2. So we'll use the tangent formula for tan theta will be the sine theta over cosine theta. We'll substitute in the values. Tan pi over 4 will be equals to root 2 over 2 over root 2 over 2, which will be equal to 1. So we found our first one, which will be 1. Next one we'll go on to, we'll use the cosine formula, which is CSC. Theta will be equal to 1 over sine theta. Okay? Oh yeah, before you... Oh, actually it's too late. Anyway, who cares? We'll just substitute CSC. Pi over 4 equals 1 over root 2 over 2, which is then equal to root 2. Then we'll just get this as one of our answers. We'll just write comma root 2. Then we'll just use the secant formula. No, the cotangent formula. What am I saying? Well, what? I don't even know at this point. Yeah, we're going to use the secant formula. Okay. here goes the secant formula. Secant theta will be equal to 1 over cos theta. Means that secant means pi over 4, which is equal to 1 over root 2 over 2, which is equal to root 2, which is going to be our next answer. I don't know why it's 2 root 2, but who cares? Then for the next one, we're going to use the cotangent formula, which is cot pi equals cos pi over sine pi, which is then equals to cot pi over 4 equals to root 2 over root 2 over... No, why am I... Okay, it's been a very long day. Oh my god. What is this? Okay. Really long day has been. Okay. Root 2 over 2 over root 2 over 2, which is equal to 1. So will be our next answer for number 1. That's probably going to be our final answer. Okay. Now for 5 pi over 3. How pretty number is that? Okay. So theta will be equal to 5 over 3 pi. Let's get into this. So we know the value is sine over 5 pi over 3 will be equal to negative 3 over 2. So the cosine will be also 5 pi over 3 will be equal to 1/2. We'll use the tangent formula again, which we all know. I'll still write it. Tan theta will be the sine theta. Oh my god, my handwriting's getting messy out here. Over cos theta, which will substitute for tan 5 pi over 3, which is equal to negative root 3 over 2 over 1/2, which is then equal to root 3. It's going to be one of our answers. Okay, next one, we're going to be using the cosine formula, which is CSC. Theta will be equal to 1 over sine theta. And we're going to do CSC. Theta will be equal to 1 over sine theta. And then that means CSC 5 pi will be equal to 3 equals 1 over negative root 3 over 2. Then which is equals to root 3 over 3. That's going to be our next answer. 2 root 3 over 3. Okay, now we're going to use the secant formula, which is going to be secant theta equals 1 over cos theta, which will just do 5 secant pi over 3. Oh my god, I can't even write anymore. 3, which is equals to 1 over 1/2, which is equal to 2. Next answer is going to be 2. Okay. Now time to use the cotangent formula, which is cot pi, which is cos pi over sine pi, which is cot 5 pi over 3, which is equal to 1/2 over minus root 3 over 2, which is equal to root 3 over 3 minus. It's going to be our final answer. Except one more. So nice, so nice, so nice, guys. Okay, last one. Example 3. Exercise 2. What am I even saying? There's a pi. So, sine pi will be equal to 0. Cosine pi will be equal to 1. So then we'll just use the tangent formula, which you already by now know. I'll just write tan pi equals 0 over negative 1, which is equal to 0. Oh well, 0 to 1 advances. 0. Then we'll use cosine formula, which is CSC over pi equals 1 over sine theta, which means, why did I rewrite that? So smart of me. Means that CSC pi over equals 1 over 0. Why am I writing sine? It should just be, okay, that's why I'm going mentally ill. Okay, which means since division by 0 is undefined, CSC pi is undefined. Really weird, right? Undefined, you know? Okay, 2 more to go. Hold on tight, guys. So for secant, we're just going to do secant pi equals 1 over negative 1, which is equal to negative 1. Okay, the negative 1 is going to be the next answer. 1 more to go, guys. That's all, and we're going to be done with this video finally. Oh, I'm not going to have to upload this now. Cotangent formula, I'm just going to say cot over pi equal to negative 1 over 0, which is undefined again. How nice. And that's all. That's all for today. Thank you for listening. Please sub and like the video. Please, bro. I spent 2 hours on this video. Wait. Please do. Have a nice day. I told you trigonometry is going to be really hard. Bye.